In December 2019, there was a cluster of pneumonia cases in China. Investigations found that it was caused by a previously unknown virus, now named the 2019 novel coronavirus. In this video, we'll take a quick look at what's currently known about the virus. Now, might change in the future. Coronaviruses are a large group of viruses. They consist of a core of genetic material surrounded by an envelope with protein spikes. This gives it the appearance of a crown. Crown in Latin is called corona, and that's how these viruses get their name. There are different types of coronaviruses that cause respiratory and sometimes gastrointestinal symptoms. Respiratory disease can range from the common cold to pneumonia, and in most people, the symptoms tend to be mild. However, there are some types of coronaviruses that can cause severe disease. These include the severe acute respiratory syndrome coronavirus, first identified in China in 2003, and the Middle East respiratory syndrome coronavirus that was first identified in Saudi Arabia in 2012. The 2019 novel coronavirus was first identified in China. It initially occurred in a group of people with pneumonia who'd been associated with a seafood and live animal market in the city of Wuhan. The disease has since spread from those who were sick to others, including family members and healthcare staff. There are many cases at present, and the disease has spread within China and also to a number of other countries. So, where did the virus come from? It's known that coronaviruses circulate in a range of animals. Sometimes these viruses can make the jump from animals to humans. This is called a spillover and could be due to a range of factors such as mutations in the virus or increased contact between humans and animals. For example, MERS-CoV is known to be transmitted from camels and SARS-CoV from civet cats. The animal reservoir of the 2019 novel coronavirus is not known yet. How is it transmitted? The exact dynamics of how the virus is transmitted is yet to be determined. In general, respiratory viruses are usually transmitted through droplets created when an infected person coughs or sneezes, or through something that has been contaminated with the virus. People most at risk of infection from the novel coronavirus are those in close contact with animals, such as live animal market workers, and those who are caring for people infected with the virus, such as family members or healthcare workers. So, how does the disease present? Well, from what is known so far, there can be a number of symptoms ranging from mild to severe. There can be fever and respiratory symptoms such as cough and shortness of breath. In more severe cases, there's been pneumonia, kidney failure, and death. The mortality rate is not known yet. How can we tell whether someone is infected? The infection can be diagnosed by a test called PCR, or polymerase chain reaction. This test identifies the virus based on its genetic fingerprint. There's currently no specific medication for the virus, and treatment is supportive care. There's currently no vaccine to protect against the virus. Treatment and vaccines are in development. How do we prevent transmission of the virus? This new virus currently has a limited geographic spread. However, there are a number of standard hygiene practices that have been recommended to protect against infection and further spread. These include covering your mouth and nose when coughing or sneezing with a medical mask, tissue, or flexed elbow, avoiding close contact with those who are unwell, the appropriate use of masks and personal protective equipment, especially in a healthcare setting, washing hands regularly with soap and water or alcohol-based hand rub. Actions that can be taken to prevent infection from an animal source include avoiding unnecessary unprotected contact with animals, washing hands after contact with animals or animal products, and ensuring that animal products are cooked thoroughly before they're consumed. It's important to stay home if you're feeling unwell, but if you have a fever, cough, and difficulty breathing, seek medical care early and share your previous travel history with your healthcare provider. That's a quick look at this emerging infectious disease. Given that this outbreak is evolving rapidly, what's known about this virus can change.
I had a little bird, its name was Enza. I opened the window and in flew Enza.
Perhaps until recently, Spanish flu has been some people call a forgotten pandemic. But it was a huge global calamity. In terms of the number of deaths, we're saying 50 to 100 million, far greater than the casualties of the First World War. Roughly around April, May 1918, when the carnage of the First World War is graphic and horrendous. But at the same time, this unknown enemy is starting to sweep through the US, Europe, the trenches, and it is recorded by the Spanish press, and it becomes dubbed as the Spanish flu because they are neutral. Well, at the time in the 1920s, they estimated that maybe 20 million had died. By the late 20th century, that figure had been up to 25 million. In the 21st century, with scientists and historians now getting together to work much more closely, that figure has now been upped to 50 to 100 million people killed. This virus killed more people in the first 25 weeks than HIV/AIDS has killed in 25 years. Horrendous. I mean, those mortality statistics are staggering.
We don't know exactly why some flu strains are much more severe than others and why some of them would be more likely to kill people or cause very severe disease.
What is particular about avian and pandemic viruses is that they replicate deep inside our lungs. When our cells detect this and trigger a very strong innate immune response, this leads to an influx of white blood cells and fluids into our lungs, and it restricts the amount of airspace that we have to breathe.
The symptoms are very graphic and very, very striking. So, it's said that some people drowned in their own phlegm. So if it was hitting or affecting the lungs, people were spurting blood from their ears and their noses. Descriptions of people turning blue or purple. So, it was really, really severe, and people just dropping down in the streets. Those that succumbed to the flu were in the age group 20 to 40 years, which is very unusual for an influenza epidemic or pandemic. And scientists and historians are now still looking to see why.
There's really two ways that people died in 1918. They either died from the initial flu infection, or they died from an enormously strong immune response to that virus where their lungs just filled up with fluids from trying to attack the virus that got into their lungs.
So traditionally, everyone sort of said, oh, well, it's the trenches, and, the conditions of the war, and that's why it was so fatal. But then you think, well, how did it spread so rapidly around the world to places that are not part of the theatre of war? I think the traditional explanation is it starts in Kansas, in an army camp, and then the troops bring it over to the trenches, Europe. But there's still many, many unknowns.
So mathematical modellers have long been interested in the 1918 pandemic, and one of the questions is to try and disentangle how it spread around the world and exactly what the routes have been. Given perfect data, you could work backwards and try to infer where it's come from. Whereabouts does it arrive in a country? Does it arrive multiple times? Or thinking about multiple countries, where is the first place? If you understand the origin of a pandemic, then you understand something about where it's come from, and maybe you can stop that in future.
Almost certainly it was a bird flu originally, but then we also know that that flu, or something very similar to it, was in pigs at the same time. Maybe it's somebody who works very closely with birds, or who works very closely with pigs, or has some other exposure like that. One of the big, really open questions in flu research and flu public health is, how does the virus adapt from one species to another? How does, for example, a virus in pigs or in birds get into humans and then start transmitting? Then the key question is, how does the virus then adapt within that person to stop being a pig virus or a bird virus and become a human virus? In other words, to be able to transmit from human to human. And it's probably some very quick evolutionary process that is going on within that human, and in many cases won't be successful, but in a few cases will, and that's when the virus can start spreading between humans and become a flu pandemic and then stay in humans as regular seasonal flu.
Flu is very difficult to eradicate because it's constantly mutating and changing its genetic information. We work on the influenza virus, and in particular on the enzyme that copies the genetic information of the virus when it enters our cells. Specifically, we're interested in how this enzyme can do this activity and how it inserts mutations in the viral genome that leads to the formation of new strains to which we need to develop new vaccines. And we are also interested in when this enzyme messes up, how it triggers the innate immune system and helps cause disease.
We really don't know why we haven't seen a pandemic as deadly as the 1918 pandemic. Scientists and public health officials are extremely concerned. The National Risk Register, which is the way that our government plans what are all the risks to civil society in the UK, there's only 2 events that are up there in terms of the most catastrophic, and that's a terrorist event or an influenza pandemic.
Cholera is an acute diarrheal disease, and it's transmitted by what's called the fecal-oral route, which means that water or food that is infected with the Vibrio cholerae, which is the bacteria that causes the disease, is then ingested or eaten or drunk by individuals, and that's how they get ill. Most cases, the people don't get very ill. They either don't really feel that they have any symptoms, or they'll have mild diarrhea. But in about 20 or 25% of those who do get diarrhea, it's very severe. They have severe diarrhea and often vomiting. The disease progresses very rapidly, so they can be fine in the morning and be very, very ill by the end of the day. For most cases, the only treatment that will be necessary is oral rehydration solutions. So it's a standard package that is diluted into clean water, and that's enough. But for those patients that I mentioned who are severely dehydrated, they will need intravenous rehydration, followed by oral rehydration, and they usually also get antibiotics. The best way to prevent cholera is for everybody to have access to clean water, clean drinking water, to have good sanitation, so you've got good excreta disposal. But we know that in these emergencies that's very difficult to have. So although we're always working on that and ensuring that people get rapid access to treatment, the vaccine gives us an additional tool to try and help protect especially at-risk populations. It's an oral vaccine, so it's very easy to administer. And it's given to all age groups, from age 1 to the most elderly of the population. It's a very safe vaccine. Millions of doses have been given and no major side effects have been reported. It's been used in many different countries now. You get some protection after the first dose, but you need the 2 doses to get full protection, and that's about 65% protection for up to 5 years.